And in this tiny little narrow range, here is all the spectra that you see. And so, okay, so here's another kind of spectrum. Now, what is shocking, what is expected out of this is that we can see lots of different molecules, and that's because we can cover in different places. What's shocking out of this is that if you look on the test gases, which is pure isotope 12, isotope 16 CO2, or isotope 13 CO2, or isotope 18 CO2, those are these markers here. And you know that these isotopes are only present to 1% or something in normal experience. But please look in Mike's breath. These isotope isolated peaks are almost as big as the non-selected isotope peaks. That means something in us is doing something with isotopes. And I promise you'll hear more about this. I don't know what, but it is absolutely amazing fact about metabolism. Now, another thing which is interesting that you'll hear about for sure 5 years or so is that the doctor will have paid somebody maybe $50,000 for this box that is bigger than a lunch box but smaller than an airplane kit. Is this mega channel cavity ring down spectroscopy can isolate individual spectrums. So for example, in a student, you could see CO. That was interesting. Carbon monoxide, we don't like so well because it bonds with hemoglobin and we can't have oxygen. This guy actually was a smoker, and that was monoxide, we don't like so well because it bonds with hemoglobin and we can't have oxygen. This guy actually was a smoker, and he said that he had quit 1 year ago. But here, after 1 year, he's emitting carbon monoxide. So does that mean he's poisoned for 1 year after that? That's an interesting thing to know, how slow it's coming out. Or maybe he's not telling me the truth. I don't know about that. This could, these students are, NO is a marker for asthma, and that's associated with this peroxidization of and inflammation of the trachea. NO shows up in the breath a day or so before the asthma attack, so that's interesting to know about. Many of you will know, you have a colleague who has diabetes, that ketones are in the breath of such a person that his breath smells sweet. In fact, we call it diabetes mellitus for that reason. And that's associated with improper insulin level. Ammonia is coming out of one with preclinical levels, easily detectable levels, before anyone is talking about renal failure or even knows that they have problems. Ethane shows up in lung cancer, and when I gave this talk a few weeks ago, a medical doctor over there just got so excited he couldn't wait until the end to come up and tell me, hey, I'm working on omega-3 and omega-6 fatty acids, and I think that one of these produces pentane and another produces ethane, and we think that the ratio of those is critical to life balance metabolism. And so here's my data about what the life expectancy is depending on what the balance of these. Okay, so it's not all bad. You have a new tool and it suddenly has a use. The only problem is, what is the ink cartridge for this business? Now you go together with your buddies, you work like crazy, you build this apparatus, you give it to the doctor, and he never needs to see you again. Now this is not the modern kind of way of having a revenue that's coming from it. Because the only thing that happens that you keep is the liability in case you get a false negative and somebody croaks and, oh, it's because the machine didn't find this. So I don't know how to cope with that one. Anyway, optical combs just give fantastic new prospects. I'm absolutely excited about this. Struggling with staying as a retired person. I'd like to say something about my staff. The guys who were involved in the comb is Scott Diddams and David Jones. Mark Nutcutt is there from time to time. We've got some wives, some young researchers. We've got a former postdoc who lives in a normal, different university, sort of like you have two universities here. Colorado has two, but they're 50 miles apart. And the best part about this, taking this kind of group picture, is that we go down to this place that has the old-time costumes and takes these old-time sepia pictures, and then Lindy has made a cauldron this big of barbecue beef. So we go to the park someplace and have a nice thing, and even the kids from this table over there come up and get in our line because it smells way better than what the other family's having. Again, I would like to come back to this respecting of the colleagues and competitors. Here is Thomas Udom, Ron Drever, continuing collaborator, and Ted Hench. And we're sitting in a research garden in Munich. These research gardens open in the afternoon about 5, and they close again about 11. And, I think we got the table cleared off before the picture was taken, but maybe these guys have something still wet on the table. And this brought an amazing experience for Lindy and me and our families and people out of the group that's worked with me. This experience of going to Stockholm. So I don't know, when this is, we're all done with questions, if anybody has 10 minutes to waste or something, I can show you a few pictures that are self-propelled, so I won't be able to slow them up, and then you can see what happens to you. You're just going along, hum-de-dum-de-dum, and then this meteorite strikes in your front yard, and your life is absolutely transformed. So, for example, this university has a gentleman called Dr. Professor Lal, and he is the most persistent person I have ever encountered. I told him no 1,000 times no, and he just keeps coming back. So finally I said, oh yeah, I would like to go to Alabama and see what it's like. So I would like to say a little bit out of this experience, if there's anything for students that's not technical. And one of these, I think, is that if you're going to do something that's significant, you're going to build it out of parts. And I can prove that, because if it was easy to do and you just buy it, there's going to be some chemistry guy or some other kind of guy that just buys it and puts it together, and you're out of luck, because you're working with student level knowledge and he's working with professor level knowledge, and he's got a whole team of paid guys in some other country. So you're going to build it from parts, and you're going to need to know about them, because how they interact is going to be important to you. So this is about broadening your knowledge base, and please do me the favor to have some broad channel in your Google filter that lets you see what happened yesterday or is within some range of science that you really don't now need to know, but you will need to know. So in your brain, I would like to build up some little sticky places like Velcro, and you go to a well-prepared colloquium sometime, the guy will teach you what he has to teach, and that's going to stick in, not perfectly matched, but it'll work. This search for interrelationships. Good people are the key resource, so this issue about showing respect, I think, is key. If you want to get continuing interest, sometimes it's useful to at least listen to what the sponsor would like and occasionally respond. So finally, is work hard, and I mentioned this, be lucky, that's important. And what I a little bit made a mistake about was working in the lab for 40 years or something, and it's only when my wife addressed me in very completely unmistakable language, which had just a small number of letters and serious intensity, I began to realize, oh, my life is nearly finished and I've never been outside. What about this? So enjoy your family life. This might be the only one you get. My team, Jun Yi, is champion. Professor Ma comes occasionally from East China Normal University, that means teaching university, not the city name, and we have great interactions, make good progress. And I feel good about the future, because this kid, grandson, would rather play with a mouse than with the real toys that kids are supposed to play with. So I thank you for listening. The further details about this stuff can be found, technical things, in the university one, and June's work now continues at twice the speed and 10 times the quality. What Lindy and I are involved in now is this SciTech's Discovery Program for kids. It's basically trying to be a gentle way of teaching parents how to take this most precious resource that comes into their life and give them a chance to really do something. So that's why I'm so excited to come to here, because what's happening is this place is giving a chance to people to really excel. So more power to you guys. Thanks. Good.
There's a microphone. You can have a microphone there, or you can speak up.
It
okay. Go ahead.
Doesn't matter.
It's okay.
Okay. I wanted to know what is the optical frequency of the microwave in the stove, because Dr. Patel was telling me when you boil water in the microwave, the particles rotate or spin.
Microwaves in your home definitely heat the molecules in that kind of way. And if you are asking about how would it be with optical fields, then the speed is much higher. And so then they don't have as big an excursion, and so it doesn't heat. So you can send a laser beam through water, but if you put microwaves on water, those molecules can respond and they heat up a lot, as you know. So it's about matching the the drive that we put on it to the response speed that the molecules have that determines how it will behave.
Thank you.
Uh-huh.
Yeah.
Yeah, you mentioned in your introduction that you might use your Swiss Army knife to look for extrasolar planets. Can you comment on that?
The project which we submitted wasn't selected. JPL project was selected, but it's the same kind of idea to build interferometers in space which have a baseline of 30 meters or 100 meters. And then we want to use that angular resolution to see something that's dark next to a sun. And so the way you do that is with optical interference. And so then if you want to get this, how much light scatters from a tiny little planet compared with how much light came from the disk, we're going to have to get this phase adjusted extremely well. So the location of these mirrors and recombining equipment is going to have to be extremely tightly controlled. This was a joint project with people at Smithsonian Astrophysical Institute. So I'm optimistic it'll come back. But now people on the ground are doing extremely well with adaptive optics. So maybe it's the right thing for the cost effectiveness of the country to use adaptive optics, which we did for another purpose. Please.
Doctor, I wonder how you envision the future of making frequency comb more and more compact. We now have the fiber-based frequency comb, and some people are trying some introduction later that way. Just curious how you envision the future, because we need to make the comb more and more compact so that find more application.
Indeed you can, and the one that I've seen is about the size of this microphone, and that's got 20 meters of fiber inside and the diode laser to pump it, and the kind of little fussy adjustments that fiber lasers need. Fiber lasers don't quite have the robustness that for femtoseconds that these other lasers do, but some of the students can find out how to put these together with just the right orientation and then press the button that welds them, and now it's together forever. So that's really a nice thing, but sometimes you have to cut off a little and do it again. So I think flashlight size is where we're heading.
Dr. Hall, you mentioned one of the motivations for you to do the measurement of speed light is to check whether or not the physical constant changes with time or not.
Yeah.
So, and my question to you is, do you believe the physical constant, like speed light, change with time? And if you believe so, what's the scale that will change with time? That's a very fundamental problem, thing in
It's indeed